Okay, Math 7 fans, our topic for today, we're starting Unit 10 here, which is similar polygons and triangles. So our goal today is to identify similar figures and determine scale factors, and then to solve problems identifying similar figures. Before we begin, let me give you your joke of the day. What did the shark say when he ate the clownfish? And the answer is, that tastes a little funny. All right, we're going to start with the idea of congruence and similarity. So congruent figures basically mean if you say that two shapes are congruent, that means that they have the same size and the same shape. Okay, I'll write it as the same shape and the same size. All right, so for example, if we take two triangles and we call them A, B, C, and D, E, F. All right? And now if they're congruent, that means that all the sides that match are congruent. Okay, so the right, those two sides are corresponding. They match up. They're the same. CB and FE, they're the same. AC and DF, they're the same. And then also that the corresponding angles, angle A and angle D, those are congruent. Angle B and angle E, and then angle C and angle F, those would be congruent. All right, so we would say triangle ABC is congruent, that's our symbol for congruent, to triangle DEF. All right, so congruence means they have the same shape, but they also have the same size. The matching sides are congruent, and the matching angles are congruent. And the word we're also going to use to say that they match up is they correspond to each other. Okay, they correspond. So A corresponds to D. We could say point A corresponds to point D, and then we could say B matches up, it corresponds and to E, and by using quotations I'm just saying the same thing from above. Corresponds to E, and then point C corresponds to F. Okay, now that is for congruence. Similar figures, they also have the same shape, they look similar, but the sizes are not the same. We say that the sizes will be proportional. Proportional size. Okay, and we'll come back to that in a moment. But if I take, here's triangle ABC again, but now if I take, here's triangle DEF. Now the shapes are still the same. So I would mark angle A and angle D, they're still congruent because the shape is based on the angles. Angle B and angle E are congruent, and then angle C and angle F are congruent. Now I'm not saying they're all congruent. This is not an equilateral or equiangular triangle. Okay, so these are similar shapes, but the sizes, you can see that A, B, and D, E are not the same size. Okay, so the way that we write that is we'll say triangle ABC is similar, so it's just the wave, that's the symbol for similar, to triangle DEF. Okay, so for congruent, it's an equal sign with a wave, and then similar is just the wave. Okay? For similar polygons, that's polygons where the corresponding angles are congruent. They have the same shape, and the corresponding sides are proportional. So this is putting together our definition. So to write it out officially, if you know that two shapes are similar, a polygon is just a shape, you know the corresponding angles, they are still congruent to each other, but the corresponding sides are not. They are proportional to each other. All right, so as an example, here's our first example. We have two triangles. Now right away, if you look inside and you look at the corresponding angles, you can see that angle D and angle L are the same. They're congruent. Angle R and angle H are the same. Now those are 68. They're not the same as 62. So when I label them, I'll use two arcs, and then the 50s are also the same. Okay, so here's what we know. If we have similar figures, I can say 6 things. I can say that angle D and angle L are congruent. I can say that angle R and angle H are congruent. And I can say that angle C and angle G are congruent. Angle C is congruent to angle G. Okay, so I know that each set of angles, of corresponding angles, they have to be congruent to each other. Okay? Now the other thing that we can do here, I'm going to write down. So actually we have 3 things with angles, then we're going to do 3 things with sides as well. We can say triangle DRC is similar. Now this is important, that D corresponds to L. So if I start here with D, I have to start here with L. And then point R corresponds to H, so they have to be the same. And then point C corresponds to G. All right, this is what we call our similarity statement. But now what do we say about the sides? All right, now the sides, if I start here, notice that that's 8 and that's 4. Right, you might see a relationship there. And then at the bottom we have 6 and 3. And then on the left side we have 9 and 4.5. They all have the same ratio, okay? If I look at 8 and 4 and I compare them as a fraction, if I look at 6 and 3, if I look at 9 and 4.5, each one of those, if we divide that, what we get is the same thing. We get 2/1. That's what it means to say that the corresponding sides are proportional. And this 2/1 is what we call the scale factor. Now, when you see this kind of statement here, we can use this, even if we don't have a picture, we can match up the corresponding sides. If I look at the first 2 letters, DR, I know that that will be corresponding to the first 2 letters, LH. And one way that I've seen this, which is kind of cool, is if you number the points 1, 2, 3, and 1, 2, 3. So if I take the side with 1 and 2, so that's DR, and then 1 and 2 is LH. All right, now how else could we compare this? We could say 2 and 3, which is RC. That side is going to correspond to 2 and 3, which is HG. And then the other ratio would be 1 and 3, which is DC, over 1 and 3 LG. This is that the sides are proportional. This is what we're saying here. Okay, so when you have this similarity statement, or if you have a picture showing that you have similar figures, okay, these are similar, the 2 triangles, we know that each pair of corresponding angles is congruent, and we also know that each pair of corresponding sides is proportional. All right, and now the other thing is I'm comparing this triangle to this one. So when I'm writing it, I did 8/4. I did 6/3. I did 9/4.5. So I kind of went from the bigger figure to the smaller one. That's a 2-to-1 scale factor. If we had gone the other way, if we had flipped these fractions here, we would have gotten 1/2. You could look at it that way and you would also be correct. Okay, so what do we know with similarity? We know that the corresponding angles have to be congruent, and we know that the corresponding sides have to be proportional to each other, which means they have the same ratio. Okay, so the scale factor, now this word here, this vocabulary, it is the ratio of two corresponding sides in similar polygons. All right, it's just a fancy way to say we divide the corresponding sides and we will get the same value every time. Okay, so let's look at a couple examples here. Number one says to find x and y if triangle PQR is similar to triangle DGA. Now the nice thing is they have given us a picture already, so you might be able to look at this and match up the correct sides, okay? But if we're struggling with that, for example, here's PR. Now it looks like that's gonna match up to DA here. Now we can tell that though, if we say PR, 1, 2, 3, PR was 1 and 3. Now 1 and 3 here is DA. Oh, and that's what we highlighted. So those do match up. Those are corresponding to each other. What I'm gonna do is circle the lengths. This is X, this length, this is 21. All right, now what else can we match up here? Well, I do see some other numbers. I see another variable here. We're gonna have to figure out the Y. I'll put that in red. Now that was D to G. DG, that was 1, 2. Well, what was 1, 2 in this figure on the left? That was PQ. So those are going to match up. And then what that means is that the bottom here, RQ, I'll do that in pencil, as 18, that's gonna match up to AG, which is 27, okay? Well, so how do we use this to solve something? We know that the corresponding sides have to be proportional. If I want to find x, x goes with 21. So x over 21. I'm going to write two ratios. X over 21. Now we could say 20 over y, and that would be correct, but we don't want to solve a problem with two different variables. So I want to use the 18 and the 27 for that. So I'm going to say x over 21 equals 18 over 27. Now I'm going to compare this. I'm taking the figure on the left and I'm comparing it to the figure on the right. So if I say x over 21, that's going left to right. I must do this one the same way, 18 to 27. Now if you said, well, wait a minute, I want to solve it. I'm looking at it as the bigger over the smaller. If you did 21 over x, okay, you can do that, but then I have to go 27 over 18. I have to be consistent. Now what we've done is we've created a proportion, so we want to solve it. The way we do that, x divided by 21, we're going to multiply by 21 on both sides because that will undo the division, and we get x equals to, right? And then you can go to the calculator and say 18 over 27 times 21, and what we get is 14. All right, now we want to find the y. Now for me, I like to put my variable on top of my ratio. So in this case, if I'm going to start with y, now the y corresponds to 20. So I'm going to say y over 20, but now I'm starting with the figure on the right. I'm comparing it to the figure on the left. So I'm going right over left. Now let's use these two numbers again, except I have to start with the figure on the right, 27 over 18. How do we solve this proportion? Y divided by 20, let's multiply by 20 on the left side and the right side to undo that division. And what we get is y equals, and when we work that out, we get y equals 30. And that's it. So how do we find a missing length? We make a proportion, and then we solve it. We make a proportion and we solve it. All right, let's do one more example here in this part. We want to find A, B, X, Y, and Z. Wow, lots of stuff. If trapezoid, trap, PQRS, is similar to trap UTWV. UTWV. Okay, now there's lots of things going on here. We have lots of variables to find. If we start on the inside, notice we have some angle measures. Here's B degrees, here's A degrees. Now, what do we know about the corresponding angles in similar figures? We know they're congruent. So here's A. Now that's for angle U here. Now U is the first letter here. What was the first letter over here? Oh, it was P. So we know that A, this degree measure is the same as this one. So we can say right away, A is 109, okay? Because they correspond. Now here's B degrees, that's angle R. R is the third letter here. What was the third letter here? W. So these match up. So if angle W is 63, we know that B is 63. All right, so right away, we know A equals 109, B equals 63. All right, now what else do we have? We have sides. Now here's X, that was PS. Let's say 1, 2, 3, 4. 1, 2, 3, 4. PS was 1, 4. In this trapezoid, 1, 4 is UV, okay, which is these sides. So we know that X corresponds to 8, so one ratio is X over 8. Now let's see, what else do we have? Okay, here's letter Y. Now that was VW for the side. VW, that was 4 and 3 for those points. 4 and 3 is SR, okay, or the bottom here. That's 18. So we know that Y and 18 go together. We have, here's the variable Z. That's the top, that's PQ. That was 1 and 2. Now U and T are 1 and 2. That's 16. Those go together. And that means that the 9, QR, goes with the 12, TW. All right, now, when I make my proportion, I have X over 8. I want numbers here. I don't want another variable. So we need to look at corresponding sides where we have numbers. Nope. Z and 16, I don't want that. 18 and Y, no. But how about 9 and 12? That will work. How do we solve the proportion? Let's undo the division. We'll multiply by 8. And what we get here is X equals, and that will be 6. All right, to find the Y. Now, if you want to keep going, I'm taking the left figure over the right. We could say 18 over Y, because they go together. And then we could use 9 and 12 again. But the way we've learned to solve proportions is we want the variable on top. So if I set it up this way, I'm not wrong, but what I'm gonna do is take the reciprocal, I'm gonna flip both fractions. Y over 18 equals 12 over 9. Now we can multiply by 18 to undo that. And what we get is Y equals, and that's gonna be 24. And then we have one more here. We wanna find Z. Z corresponds to 16, so Z over 16, and this was the left figure over the right, so I can say 9 over 12, left over right. And now to solve it, let's undo the division, multiply by 16, and what we get is Z equals, and that will be 12. Okay, so we just do a piece at a time. We do one piece at a time, and the problem works itself out. You just have to make sure that you match up the correct sides and that you do them in the same way. And that's the end of part 1.